Welcome everybody. Give it a couple of seconds for people to join in Zoom. Great, numbers are coming up. Give it a few more seconds. And I will kick us off. Can you see my screen, Shazza? Fantastic, good. So welcome everybody to our webinar today. We've got some really exciting content planned today. Really pleased with what we're going to be able to show you in over the next hour. So today we're going to be building monetization and engagement strategy on our Endless Runner game from start to finish in Machinations. So if anyone that's with us today that was in our last webinar, great, a lot of this will make sense to you. If you weren't in our last webinar, don't worry. We're really just going to focus on some different areas and show you how to use the Machinations platform. Before we get started, what would be great is if down the bottom of your screen somewhere, you'll see there's a chat button. If you could open up the chat button and just change the option here from all panelists to all panelists and attendees. And then it'd be great if you could just let us know where you're dialing in from and which studio you're from. That'd be great. Hello, Said. Great, coming in quickly. So I'm Matthew, I'm our evangelist. I'm going to be working with Cesar today, our diagram craftsman, and we're going to be going through and building out this model. In chat, we have Mihai, our CEO and founder, who'll be lurking about in there. So if there are any questions that come up that we don't get a chance to jump on while we're building the model, Mihai is going to be in the chat answering any questions that you have. As always, this is going to be an interactive webinar. We're going to ask for your feedback throughout. Please do ask questions in the chat and we'll jump on them when we can. And as always, we're going to be asking for your help and guidance in building the model via polls. So I'm going to stick our very first poll up, as always, where it's a quick survey of how complex your machinations are so far. For those who have never used it before, all the way through to you're building some full meta systems. I'll give it a few seconds for that while I seamlessly transition over into our model. Great, Cesar's on here with me. I'm going to turn my grid off because I know that looks slightly better. So for those of you that were here, I'll just end the poll and share the results. Great, so a lot of people not used it yet. We've got a few doodles and people already doing full subsystems. Fantastic. So here's our model that we built last time. It looks super intimidating if you've not seen this before. So I'm really going to quickly just run through what this system's doing. I'm going to slow it down a little bit and hit play. So here's our little player. Our player is our orange counter. For those of you who were here last week, we built a number of these models. We found that in our practice runs, it was really boring watching the player go through that onboarding process. So we've just kept it to our last model where we've created a loop at the end. So the player creates some distance, their difficulty factor increases. As they go through the game, the number they're earning coins. In the last webinar, we added 3 boost mechanics, one of which just triggered, which is a speed boost, which makes the player go faster. The second of which was a kind of a strength boost so that the player can smash through all the obstacles and can't end the game. And our third one just triggered, which is our mega ultra galactic jump, which is where our player leaps into the air, jumps a whole distance forward and earns a whole bunch of coins. At the top here, we have our little loop system. Players just gone through it where while they're in the game, they're in this pool. When they lose all their lives, they move over into our reset pool, which resets our board. They go into a new game, and then the player comes back into our in-game pool. And they carry on that cycle. Over on the right-hand side here, we've got a little counter that we've added, which just counts how many games the players had. So the first thing we're going to do is let's just talk about monetization. I'm going to launch a poll. And what we've been thinking of, we've thought of a few ways that we can then monetize this game. We're going to have the ability for them to watch an ad for an extra life, be able to buy tokens to get an extra life, and also have a system where the player can earn new characters and skins as they go through the game. While I do that, I'm going to seamlessly transition. I'm going to stop sharing and I'm going to pass over to Cesar. Cesar, welcome. If you want to share your screen, and I'm going to end the poll in a couple of seconds. It's very close. I'm going to end the poll in 3, 2, 1. There we are. So actually, our most popular one is to have a skin system where the player can earn new character skins. Fantastic. So let's build up to that one and build that one last so we can focus on it. We've got watch an ad for an extra life, or I've spelled ad wrong, but never mind, and be able to buy tokens to get an extra life as well. So let's kick off with watching an ad to extend their gameplay.
Yeah, hopefully everyone can see my screen. I'm just going to focus on our player loop rectangle that we have here, because this is where we'll be doing most of our construction in the beginning. So as Matthew said, the first thing we're going to be doing is we're going to add a chance for our player to receive an ad when losing all of his lives, and watching that ad will grant the player 1 extra life so he can continue his run. Now, this is going to be a limited sort of opportunity, so the player's not going to be able to keep spamming ads in order to continue gameplay. The amount of ads that the player can watch, I believe, is up to debate. Am I right?
Absolutely. So I'm going to launch a poll. How many times should the player be able to watch an ad for an extra life? So we've got 1, 2, or 3. We thought 3. Over 3 is just going to start to get crazy. So pop in there how many lives you think, extra lives a player should get from watching an ad. Fantastic. Votes coming in quickly. Perfect. I'm going to end the poll in 3, 2, 1. And actually, it looks like we're going to be super tight with our player. They can only watch 1 ad for 1 extra life.
That's fine. It's the most convenient one for me, so I'm happy.
Perfect.
So we're gonna only give the opportunity to the player once. So the way we're gonna implement that is we're gonna mess a bit with our player loop system here. So I'm just gonna delete this connection here, and instead of always resetting, the player will now have a branching path when losing his last life. So I will be adding a gate in here. It's going to be a random gate based off percentages, because the player can watch an ad based on a chance. We're still going to have our reset mechanic in. I'm going to use a chance of 100% for the reset, because you're going to see that we're going to be disabling the other options as the player uses them. So in the case that we had, let's say, a 50% chance for reset and we disabled all other options, there would be a chance that our gate here just eats up our resource and our player is doomed. So we want to make sure that he always goes through reset. Having total chances over 100% is fine, because they normalize towards 100% anyway. So having 100% here and 50% chance somewhere else just means that there's double the chance for the player to enter reset. I'm going to create my second option here, which is watch an ad. I'm going to place it a bit to the left. So at the moment, of course, the chance of watching an ad should be less than 100%. But because we want to test out the mechanic, we kind of want to force the player to watch the ad. So I'm just going to inflate the chances a lot. So I'm going to make it 2000%. So it's almost certain that the player will watch an ad in order to revive. The first thing we want to do is close out the loop. So if the player watches an ad, he then transitions back to in-game without going through the reset process. So he still retains his distance, his difficulty factor, and all of the stuff he accumulated during the run. We're also going to have to keep track of how many ads the player has watched this run, because we want to limit him to only 1. And we're also going to want to actually give the player his life back. So how we're going to do that is we're going to be using a source. I'm going to leave it automatic and have it conditioned by our, let's call it watch add for revive pool. There we go. Since our resource is only going to be here for a single step because the in-game pool is going to draw it immediately, then the condition is fine. Our source will only be active for a single step when he's going to push all his resources. Now, the first thing we want to push is lives into the player. So I'm going to let Matthew tidy that up. I'm going to leave the label to 1 because it's going to give 1 life to our player. The next thing that we want to do is count the total amounts of ads that we have watched. This can be useful for tracking purposes, and it's as simple as adding another pool here. I'm just going to name it total ads watched. And this can keep track of the entire amount of ads that we have watched since execution started. We might want to see it as a number, so I'm just going to go to the display property, switch it to -1, so we can see it as a number rather than the tokens that we have here. And thirdly, but still very important, is the limit that we impose on the player. So only 1 ad per run. That's why we have to keep track in another pool of how many ads has the player watched during our current session. So I'm going to name this ads watched, maybe even type it correctly, during this run. There we go. And we're going to be using this pool to disable the chance for the player to watch an ad after he already watched one. So since it's 1, the condition is going to be fairly straightforward. It's going to be just smaller than 1. So as long as the player hasn't watched any ads, this option is available for him. This branch is available for him. As soon as he watched an ad, he triggers the source, generates 1 resource here. The condition then disables this path, and the player is forced to reset after watching that run. So we can test the mechanic right away. I'm just going to make the speed a bit slower so we can see the transitions. Our player starts with 2 lives, so he should lose them fairly quickly. So let's see, we're going to be focusing on the player journey here. I'm not going to show the whole diagram. And we're just going to be waiting for him to lose his lives. Now, since it's only a one-time opportunity, there we go. He watched his ad. Now this path is disabled. We've counted the number of ads watched. We've added the life to the player. We're waiting for the player to lose that life. He's going to be forced through the reset loop. And you see, this is where we forgot to do a very important thing, which is also reset the number of ads that we watch this run, because as it is right now, it's just going to permanently disable this option. So what we need here is a drain node. I'm going to be placing somewhere in the middle. I'm going to make it automatic. We're going to use this drain to reset things that we gathered during a run. And I'm going to need a state connection, not a resource connection. We're going to be using our reset pool for that. So reset greater than 0 means that whenever our pool reaches the reset, whenever our resource, reaches the reset pool, we can drain our ads watched during this run. Now, normally a label of 1 is fine because we're never going to gather more than 1. But just to play it on the safe side, I'm going to label it all. So it just completely drains the pool, so there are no problems here. Now, I'm going to simulate it again. This time it should run fine. We should have no more problems. But again, simulating like we did earlier is important in order to find any mistakes that we made. So it helped us learn the fact that we are not draining the ads that we watched during a run, and we're just permanently disabling the option for the player. So now he's watched an ad. Hopefully when he resets, he's going to reset the counter as well. There we go. The option is now available again during a new run. We still count the total number of ads. So it's all working as intended. I'm just going to let the player watch another ad just to make sure that it works again. And then we're going to move on to our next mechanic. There we go. Okay. I'm just going to stop execution.
Well, props to
hopefully,
Anton in the chat who spotted that you missed out that drain the ads well before we did.
yeah. Good job. Good job. Yeah. So our next mechanic is going to be our hard currency. So we're going to have a currency that's only obtainable by spending real money. We've named it keys, and we're going to use it for the same mechanic that we used ads. In order not to complicate the diagram too much, we're going to be using for reviving the player as well. There are going to be some differences this time. The main difference being that you can use this mechanic an unlimited number of times to revive the player rather than just once. But there is a trick to it, and I'm going to show you what it is, and I'm going to walk you through it. Now, our key purchase system would be rather tedious to build and boring to watch. So what I've done here is I've opened our library, which is sort of a storage for all pre-built systems that we can make and save. I've opened up my team folder since I'm sharing the same team with Matthew. I'm just going to be borrowing his key purchase model that he built yesterday, and I'm going to place it on my canvas here. And I'm going to walk through what it does in a minute. Just going to place it conveniently above our player loop. So hopefully I'm going to zoom out for a bit. There we go. So let me explain this model real quick. The source generates one resource that acts as a chance to purchase. It goes through a random gate with a 10% chance of actually completing the purchase. Of course, the number is unrealistic. In reality, it's more like 1% or even less than 1%. I think we're missing a connection here, but I'm gonna place it right now and hopefully arrange it the same way. Yeah, and I'm gonna give it a 150 and do the orange coloring that the others have. There we go. That was an easy fix. So there's a 10% chance we actually complete the purchase. And once we complete the purchase, the purchases have various values and give various rewards. So we can have up to a $50 purchase. We can go lower, 20, 10, and down to $1. The lower the purchase, the higher the chance that we have. So it's 50% for a $1 purchase and only 3% for a $50 purchase. And all of these purchases convert into our hard currency, which is keys. So we use a converter, we turn $1 into 3 keys, $3 into 10, and so on, up to $50, which is 500 keys. And this is where we keep track of our keys. This is the pool that we'll be using to spend those keys in order to revive the player. And we're going to be using the drain to actually remove keys whenever the player revives. So we need to connect the system that we have here to our player progression system that we have below. Now, we're going to be using the new game pool in order to trigger our chance. So we thought that the player should be only receiving a chance to purchase while in the main menu, so not during gameplay, not during the reset phase. So while the player is in the new game pool, which acts as sort of a, let's say, main menu phase of the game, he's only going to be in here for a single step. And that's the step when our source gets the chance to fire the purchase chance. So I'm just going to leave it greater than 0. The condition is fine. And we trigger a chance to purchase keys. Now, since the chance is fairly small, and I'm going to want to test the mechanic right away to see how our keys behave, I'm just going to give our player an initial, let's say, 200 keys that he's going to have to work with in order to trigger the revive mechanic. So let's implement that revive mechanic. We're going to do it next to our add mechanic. So things in here are about to get a bit crowded. So hopefully you won't have trouble following. I'll try to explain it every step of the way. So the first thing we want to do is adjust our chances here. Our watch ad for revive, we're going to make it a 20%, let's say. It's not that uncommon for a player to watch an ad in order to prolong his run. So a 20% should be fine. And the first thing that we're going to do is we're going to add a new branch for our player. Just going to have another pool here. And The third branch will be using keys in order to revive. Of course, we're going to need chances for that as well. And at first, I'm going to inflate the hell out of those chances because we want to make sure that our player actually uses those keys. So I'm just going to leave it at 2000% for now. We can also name the pool use keys for revival. There we go. So this is going to signal that the player has used keys and is going to gain 1 extra life. The first thing we want to do now is make sure that we close our loop. So the same as we did with watch ad for revive, we're going to be sending our player back to the in-game pool. I'm going to leave the connection here. Matthew can arrange it if he wants. So the mechanic that we have to implement is basically the same one so far as watch ad, but it's going to get a bit more complicated in a moment. So we're going to be sending a life to the player again. So I'm going to need a source here, which we're going to condition greater than 0. We use the key. That's great. Let's pump a life into our player, who's hopefully reached 0 by that point. I'm going to drag it a bit to the left and let Matthew handle that.
I'll tidy that up.
Yep. And the twist that we had in mind is, since using keys is repeatable, obviously the players may be able to use them 100 times, let's say, during a run, which shouldn't be fine. So we thought of increasing the cost of keys needed to revive after each revival during a run. So the first revive during a run should cost 1 key. The second one should cost 2, then 4, 8, 16, and it should just be an exponential increase. So at some point, the player decides that it's not worth to use that many keys for gathering another, let's say, 200 meters of distance. He'd just rather start a new run and use 1 key again. So the way we're going to implement that is we're going to use a register, which I'm going to place here, which is going to dictate the amount of keys that we drain with each revive. As you see, our label here is currently 0. That's because we will influence that rate by using our register. So what we're interested in is how many keys have we used, or rather how many times have we revived using keys during our current run. So to keep track of that, it's going to be a system similar to ads watch during this run. Just going to place a pool near it, count it every time the player uses a key. I'm going to count that he used the key. Let's see, times keys used for revival, let's say. Labels are getting rather long. And we will be using this pool and the contents of it as a variable in our register. So I'm going to send it. As you see, the label defaults to A, which means that I'm going to send the value inside of the pool as the variable A inside the register. And this is going to be where we'll be doing our funky math stuff. It's going to be a simple formula, which is pow 2 and A. So this formula translates to 2 raised to the power of A. So when we have 0, it's going to be 1. When we have 1, it's going to be 2, then 4 and 8, and so on and so forth when the cost increases. And this is going to be the cost. I can also name it just before the label, type cost and add a colon. So this is going to be our title, and what's after the colon is the formula. And our cost here is going to influence the amount of keys that we drain whenever the player uses them for revival. So I'm just going to add the +1. The +1 by default is fine. It means that plus means that we add the value inside the register, and 1 is the amount that we multiply that value by. So we're going to multiply it by 1. So we're just going to add the value inside the register to our flow here. Now, in order not to repeat the same mistake that we did before, since we will be using keys, it's important to drain them whenever we reset. So I'm just going to connect our times key used for revival pool to our reset here. And again, I'm not going to risk it because there's no telling how many times we'll be using keys. So I'm just going to label it all, so it completely drains our pool. So at this moment, we have our keys, they revive the player, we accumulate them, the cost increases every time, but we also have to add two more things. The first one is the player actually has to use keys when reviving. So that's the simpler part. We can just trigger our drain here. So we're going to use keys for revival. Whenever we receive a resource here, we will be using an asterisk, which is our trigger label. So whenever we receive a resource here, the drain will execute a single step. As you see, the drain is passive by default, so it does nothing. It will only be activated by the pool when receiving one resource. It will drain during that step and then become passive again until triggered later. And the other thing that we want to keep in mind here is that the player actually needs to have the amount of keys required in order to use that revival. So he can just revive with a cost of 500 if he only has 50 keys. So we're going to have to keep track of that as well. And we will be doing that using a second register, which I'm going to have to be cautious with my space here because it's getting cramped. This is where we'll be comparing the amount of keys that the player has to the cost needed in order to revive. So we're going to be needing two variables, which we're going to be getting one from our keys pool, it's going to be A, and one from our cost register, which is going to be B. Inside here, we're going to be using a comparative function to check that the number of keys is higher than the cost. A comparative function like, let's say, larger equal. And I'm going to type A and B. So what this function does is it checks if A is larger or equal than B. And if it is, it returns a value of 1. And if it's not, it returns a value of 0. So as long as we have enough keys, this register should be 1 constantly. And as soon as we don't have those keys, it should become 0. We will be using this register to condition our branch, our key revival branch, as we use the adds watch to condition our add revival branch. We're interested when the player has enough keys, then he's able to use those keys in order to revive. So I'm just gonna connect it, and the condition is gonna be greater than 0 because then the A is larger than B, so we have enough keys for the revival. And by the way, for all of you at home, I hope you have a colleague like Matthew that's going to help you tidy up this stuff, because it really helps you focus during building.
Trying to keep it neat and building it is tough. I'll try and make it tidy.
Yeah. So right now, I think the system is pretty complete. I don't think it's missing anything. In order to track what's missing, I'm just going to hit run and see what happens. With our inflated chances, there's a huge chance that the player will use keys in order to revive. So I'm just gonna, hopefully it will go through and not reset or do anything else. Let's hope we don't get unlucky. So we're waiting for him to lose his life. Hopefully he's gonna use keys for revival. And I'm just gonna let the cost increase until the player doesn't have enough keys to revive, so we see what happens. So we see we use the key, the cost became 2. Now it's going to drain 2 the next time we use it. There we go. Because we're keeping track of how many times we've used this mechanic, it's up to 8 right now. So it keeps draining keys. Because of the chances our player is going to keep, probably going to keep reviving using keys. We're at 16. And because it's exponential, it's going to quickly spiral out of control. But luckily, we've built out our player with no self-control. Oh, he hit reset. Okay, that's fine. That's fine. You saw the mechanic. As soon as the player would have run out of keys, the option would become unavailable. Hopefully, I'm just going to leave it again and hope for the best. Maybe this time we won't get unlucky. We're already at 16. When we reach 128, it should be done, hopefully. 32, yeah, the next 2 should be the last ones. There we go, he revived again. He's at 64. He has no self-control, he's just wasting all of his keys. Now, our path is disabled because he no longer has keys. So he can either watch an ad or just reset. He reset. We've reset our times keys used. We've reset the cost, and he's back to using keys again. So that works as intended. This time we've successfully built it without no mistakes. So this is our second model for hard currency. Obviously, it can be used for other mechanics as well. It can be used to gather a lot of distance. It can be used to generate boosts. It can be used to decrease difficulty factor, add a bunch of coins to the player, or of course, many different mechanics. But we've been focusing on revival today. Now,
this is fantastic. So we've given the player the ability, so effectively they can earn additional soft currency, which is our coins, by watching ads, so that they, they're in the higher scoring areas and they can earn more. But now we need to give them something to kind of shoot towards and create some skins. So how can we build a kind of a cosmetic system?
Yeah. So fortunately, the thing with skins that I particularly like is that they don't really influence gameplay in any way. So you can just build a separate branch somewhere, and you don't have to connect it back to your whole main model, which can sometimes be a headache. So I'm just going to be using the library again, since we have it partially saved. As you see, our initial model was with 5 skins, but we've reduced it to 2 skins, and I'm going to be adding the third in order to explain it. I'm just going to add our model here, skin generator. And I'm going to be explaining what all of this means because I'm going to be building another model up here. So the way we thought about skins is that the player will be receiving a random amount between 1 and 2, which is signaled by the label here, D2, which means a two-sided dice. So the result can be either 1 or 2. He's going to be receiving either 1 or 2 skin shards per run. And those chances are going to be random. You can see that those chances are whole numbers here. So you can use random gates with whole numbers as well, not just percentages. A whole number roughly translates, so a 1 on a label translates to 100%. So a 20 would translate to 2000%. But since both chances are equal, both are 20, they are effectively a 50% chance for each of them to trigger. I am going to be adding a third option here, which is going to be our most likely skin shard to obtain. I'm going to increase the odds there. So the first pool, the one on the left that you see here, is used to keep track of our skin shards, the current amount of skin shards that we have. I'm going to align it with the others and set the display to -1. So it's similar to the other. This is going to be the container for our skin shards. I'm going to connect it to the random gate as well. Use the same layout as Matthew did. And as I said, I'm going to be giving it a higher chance, 50, let's say, which means that it's going to have twice and a half the chance of getting the skin shard rather than the other 2. So this is going to be our most common one. Now, the way we thought about it is that the player can use the amount of skin shards required, which in our cases here is 10 and 15. The first one is going to be the cheapest one, and an amount of coins in order to unlock a skin. So you're going to need both skin shards and a required amount of coins to convert those skin shards into a skin. Of course, the converting part is going to be handled by our converter node. I'm going to be placing and hopefully aligning with the other nodes. I'm going to set it to automatic and pull all. We want to set it to pull all because it has to wait for the required amount of resources before it attempts to convert. If it was set to pull any, then as soon as the pool would receive resources, it would attempt to convert and fail because he wouldn't have the required amount. Setting it to pull all makes the converter wait until we have the required amount of resources here. And since this is going to be an easy skin to obtain, I'm just going to make it so we need 3 shards in order to complete our skin. And as soon as we have the 3 shards and the required amount of gold, which I'm going to connect later, the converter will turn those shards into 1 skin. So our final pool here is going to track the fact that we obtained skin 1. So I'm just going to name it skin 1. I'm going to leave it at that. And as soon as we have our skin, another thing that we thought about is helping out the player. So when you obtain your skin, obviously getting the same skin shard is going to become irrelevant because you no longer need them. So we're not going to let the player accumulate these shards any further. As soon as he has the skin, the option to gain those shards becomes disabled. So we're just going to be using our skin pooling here to disable the other components that we have. This is not aligned perfectly. Now it is. You can check when switching a connection to a straight angled one like this. You can see that it turns to not a straight line if they are not perfectly aligned. So you can check if your nodes are aligned or not. Now, since it's a straight line, I know that my nodes are perfectly aligned. So this is going to be a condition like less than 1, because as soon as we have the skin, we no longer need to convert it, and we no longer need to gather skin shards. So this is going to be less than 1 as well. Gonna change it, and there we go. And another thing that we've been considering is maybe since we're going to be using both coins and skin shards, maybe the player is going to be bottlenecked by the coins. So he'll reach the amount of shards that he requires fast, but he won't have enough coins to upgrade the skin, and he'll keep getting those shards, even though he doesn't need them anymore. So we're going to have the player even further. Of course, this is up to every game designer's choice, but our choice is to be friendly to our players. So we're just going to be disabling the option to gain more shards once you have the required amount. So we're going to be using the shards pool. The condition is going to be less than 3 because we convert 3 of them, and we're just going to disable the option to gain more shards. As you see, where we have 10, the condition is less than 10. When we have 50, the condition becomes less than 50. Now, I'm not going to need this source. I can use our game generator. This source placed here, as you see, it's only triggered by reset. So it only pushes a node when the player resets. It's used for 2 things. It's used to generate player skill. So assuming the player actually learns from his mistakes and improves with every game, his skill increases. So he's going to get further. This is a formula that Matthew built. And it also counts our runs, so we can keep track of how many runs our player has completed throughout an iteration. I'm also going to use it to generate our skin shards. Going to leave the label to D2. It's going to generate between 1 and 2 of them. And now I'm going to have to align with what Matthew did below here. As you see, he's connected the required coins as well. So I'm just going to connect coins to my final construction. I'm going to drag it a bit. Gonna let Matthew handle the fine stuff, but first I want to talk about the label. It's the same idea that we had at the register. You can also name this one, let's call it coins, and we're going to give it an amount of 800 for starters and see where that goes. So the only part that's going to be considered by the label when transferring resources is the 800. The coins is only there for naming.
Super helpful way with a diagram like this, when you look back at something and go, where did that come from? And actually, I just find just putting a label on there of coins and then the number just helps me keep track of where everything is.
Exactly. At the moment, we can simulate and see what happens. So maybe we want to keep track on how fast the player gets his first skin. Is that right, Matthew? Is that a fine?
Yeah, absolutely. So we've got a quick poll. Obviously, this is going to be the first skin that Cesar's just built. How many games should a player have to go through to be able to unlock that skin? So I've kind of added some options there: 3, 5, and 10. Maybe if we split it, we'll go somewhere in the middle. Looking like not many people want to do 10. Perfect. I'm going to end the poll there and share the results. So our most popular is 5, but 3 was pretty high. So somewhere between 3 and kind of 5 would be ideal. So how can we use our model now to work out what those numbers should be?
Yeah. So I'm gonna try and build it for 5. Obviously, results may vary. So it's probably gonna be somewhere between 3 and 5. First thing we want to do is we want to keep track of when the player has actually obtained his first skin to see how many games he currently plays in order to obtain that skin. So we don't want for the whole run to finish executing. We're not interested in that. We're only interested in the point that the player gets his first skin. This is where an end condition node comes in. An end condition node is a node that immediately stops execution as soon as its condition is satisfied. So my condition in this case is going to derive from the skin 1 pool, is going to be greater than 0. So as soon as the player has got his skin, I'm just going to stop execution. I don't care what happens after that point. So this is going to be a way to track of how many games the player needs in order to unlock that skin. So I'm going to be using the chart. I'm going to be adding run count inside the chart. We're keeping track of coins as well. I'm going to leave that there and clear it. And we're going to just do 5 quick runs. So I'm going to multiple run for 5 runs, as you see here. It's 1,000 steps, but it's never going to reach 1,000 steps because the player is going to unlock the first skin and is going to stop execution. So let's just do a quick run at first and see what happens. Yeah, so this is my bad. Just a second, I'll let it finish. He's at 2 shards right now. He's got his turn. Okay, so as you see, we can't really track run count. We can see that it's 6 in the pool, but when doing multiple runs, it's gonna suck. So I'm gonna have run count and set it to right scale. So it's gonna use the scale on the right. The coins is gonna use the scale on the left, and we can track them separately and see them. So now we can see that we reached 6 during our run. So I'm gonna clear the chart, reset, and we're gonna do our 5 runs and see what our average becomes at the moment. So we are at 4 for the first run. Second one went quite fast. Our third run is at 4. Our fourth run went quite fast again. So our player is pretty good and he's getting pretty lucky with the shards. And our fifth run. So we can track each run individually. I'm taking a look at the last. We had 4 runs. This is 2 runs. What do we have here? 4 runs, 2 runs, and 4. So it's below what we want for the player. That means we need to fix this, and we're going to fix this in a couple of ways. So the thing is, if you keep track of the runs right now, so I'm just going to highlight, you can notice something really important here. As our runs increase, the moment the execution stop is when there's a sudden drop in our coins. That means that the player is spending his coins in order to gain the skin.
Tell you what, Cesar, one thing that could be impacting this is if you just check how many keys you're giving the player at the start of the execution, you'll see, I think we're not giving them any. Okay, that's fine then.
Yeah, it could have, you panicked me a bit. I thought, hey, did I forget the keys in there? It could have been, yeah. Or are the chances not? Yeah, that's it. There's the chance for using keys.
That's it. I knew there was something throwing that off.
Yeah. See, that's why it's important to have a partner in situations like this. So I'm just going to reduce the key chance to 10%, let's say. It should be fairly rare, and it's probably not going to occur more than once or twice in a single run. Going to leave all the others there. And we get 0 keys, which is fine. Let's clear the chart. But telling you what just happened means that our player actually made purchases and gathered keys. So we're getting rich here in this scenario. Right, so I'm just gonna run 5 more times with our new conditions without reviving as often. See how it goes. It's gonna probably take more runs for our player. There we go. Exponentially more runs. We're getting up to 20 almost. So the difference is quite high. Good thing that Matthew noticed, or we would have been balancing the wrong thing to begin with. Yeah, so we can keep track of them now. This was our best performing one, so to speak. We had only 11 runs here, 14, 19 again, and 14.
Now, one of the really interesting things there, Cesar, you can see in the chart there that the number of coins is dropping to just about 0 every time. So
Exactly.
it's probably meaning that they've got the skins, but they're not getting the right number of coins. Exactly. So how can we see how many coins a player's getting when they've filled up their 3 skins?
So as you see, as Matthew mentioned, the coins are our problem here, not the shards. We're getting the shards, but as you see, the purchase is made as soon as we get the coins. So the coins are our bottleneck. I'm going to clear the chart. And what Matthew is referring to is we should be checking as soon as the player has his shards, how much coins does the player have at that point. I'm going to leave the end condition here. We can have multiple end conditions in a single diagram because it's going to trigger when we reach our 3 shards first anyway. So this one won't matter. And I'm just going to be using our skin shard pool in order to keep track. So since we can, in unlikely scenarios, gain 2 shards and both go into our first one while we already have 2, that means we can go over 3. So I'm not going to put the condition equal to 3. I'm going to put it greater than equal to 3. And that's the point where we're going to be stopping our execution. We're not interested in run count, so I'm not going to make it visible. We're only interested in how many coins do we have when we have our 3 shards. So let's just multiple run and check out our coins. That spike, I believe, was a mega jump right there.
Yeah.
You can always track mega jumps easily by large spikes. So our final run was a bit odd. It was shorter. We got our skin shards fast. We only had 161 coins. In the other runs, we had 342, 145, 248, 416. So the average is quite, the range is quite high. It really depends on player luck. But a safe assumption is that around 300 coins, the player should be having his 3 shards, unless he's quite unlucky. So a cost of 300 to 350 should be fine. We're just going to make the cost, let's say 350, and see how that goes. This is all part of balancing. So it's as simple as changing a number and see what happens. So now I'm going to delete this end condition. We're going to make the run count visible again, and we're going to see where the player, how many runs it takes for a player to unlock his first skin. So I'm just going to do 5 multiple again and see what happens. We got to 12 there, still getting a high amount. This one was faster. Again, gold seems to be the bottleneck, so I'm just going to reduce that even more. The final run was fine. We got only 4. But as you see, gold is still our problem because the point of buying gold is the point that we need our shards. So I'm going to decrease it even further. I'm going to make it 250 this time. I'm going to clear. I'm going to do 5 again. They run quite fast, so doing 5 is fine. We get the results pretty fast. As you see, the first one was pretty odd. It went for a long time, so we got like 11 games. But the ones that followed, we got 2 runs, 5, 3. So the balance is probably somewhere between 250 and 350.
I think we had lots of votes for 3 and lots of votes for 5, so I think that's pretty much perfect.
It's fine. It's probably around 300, let's say. I'm just going to leave it at 300 right now. Not going to focus on this too much. The point is we keep trying coins until we find the perfect amount. It's always going to be up to randomness anyway, since we get charts based on chances. So a curve like that is pretty fine, ranging between 4 and 5. It's about right. I'm just going to delete this condition now.
Nice. So I guess the next question we're going to have is, how many games then should we have to unlock the second skin? And with the second skin, we're then going to look at another mechanic for it as well. Place your votes. Should it be 5 more games, 10 more games, 15 more games? Nice. Votes coming in. I'm going to end the poll in 3, 2, 1. And the poll, share the results. So most people are saying kind of 10 games. But let's see how we can really balance this well and see how we can maximize the chances and maybe introduce a new monetization option at this point.
Yeah. our second skin is going to be our chance to become greedy. So what we're going to do for the player is, since he needs 10 skin shards, first thing we want to do is track the amount of coins that the player has when obtaining, let's say, 7 skin shards. So he's more than halfway done, but he still needs a few shards to complete that. So I'm just going to add another end condition, make it greater or equal than 7, and we're only interested in our coins, so I'm going to make run count not visible. We're going to do 5 quick simulations. These ones are going to be longer. You can see in the coins a sudden drop. That's when the player buys his first skin, and it's probably going to be constant. Okay, so this is our final run. He had 281 at that point, 353, 262, 236, and this one's a lot bigger, 631. So this is probably the odd one out because it's inconsistent with the other executions. He's around 300 coins usually. So what we want to do for our player is we're going to adjust the cost of our coins in order for him to have the required amount of coins as around the time he hits 7 skin shards. So we're going to leave it at 300, let's say, which is going to be similar to the one above. I'm going to space that here. We're going to leave it at 300. What we're going to do for the player is, as soon as he reaches those 7 skin shards, we're going to push an offer to him in order to buy the remaining 3 skin shards and complete his skin, since he's going to have the coins for it. So he wouldn't need to play more games in order to unlock it. So how are we going to do that? We're going to be using a register, first of all, because we'll need to keep track of how many shards the player has and how many coins the player has. We should only push the offer when he has the necessary amount of coins in order to make the purchase and get the skin. I'm not going to be using a resource connection. I'm going to be using a state connection, which I'm going to draw from coins. We're going to send it as variable A. I'm going to let Matthew handle the mess. And we're going to be sending variable B from our skin shards pool. And what we're going to be doing inside is we're going to check if both conditions are true. So again, we're going to be using comparative functions, larger equal. The coins will be comparing to 300, so we have at least 300 coins. We're going to multiply this, larger equal, and we're going to check that we have at least 7 skins. Now, we multiply this because the results are either 0 or 1, so it works like a logical AND. The result is going to be 1 only when both conditions are true. And we're going to use that as an activator for our offer. So when this is greater than 0, this source is going to push our offer to the player. The offer, much like our player, will have a branching path. The player can either accept it or refuse it. It's going to be, of course, a random chance, and it's a fairly low chance that the player will accept it. But for our model here, we're going to make it a 50-50, make the chances fair. So I'm going to be using a pool. This is going to be keeping track of the fact that the player refused it. So it's either going to be 0 and 1 or 1, because we're only going to push the player this offer once when the player reaches the amount of skin shards. And the other option is the player actually accepts it and turns it into the other skin shards. So we can straight up use a converter in here. Just with that chance, let's make this 50% and make the other one 50% as well. And the resource in here, we're just going to convert to 3 skin shards, send it straight to our skin shard pool as the remaining 3 that the player needs. So hopefully at that point, he'll be able to complete his skin as soon as he makes the purchase. Now, at the moment, because of the way this is built, if the player successfully buys, then all of our conditions in here will kick in and will disable the chance for the player to buy again. But if he refuses the offer, then it's just going to keep sending offers to the player, which of course can become annoying. So we only wanted to trigger once. So instead of conditioning the source this time, which is already conditioned by something else, we just condition the research connection that we have here. I'm just gonna try and make this look good. So if the player hasn't refused it, fire it. Otherwise, don't bother our player again. So it's just a less than one in here. So now our offer should be firing as soon as our player has the necessary resources, and he should get the second skin. Now I'm gonna make run count visible, and we're gonna see what results we get with this offer and how many times. We can also, let's keep track of how many times the player refused our offer. I'm gonna make it purple and show it in chat. It's either gonna be a 0 or 1, so I'm just gonna use right scale like run count so we can see it there. So I'm just gonna multiple run 5 times and see what happens. Oh, that's my bad, sorry. I should also stop execution when we get our second skin. Yeah, so add an end condition, add a greater than 0. There we go, clear the chart. Go again. So the first one was 13. The second one was much faster. The third one was much faster. Now we keep going and going. Got to 20. In some of those executions, the player actually buys the second skin before the first one. So in this execution, our player took the offer. No, he didn't, because we have 1 in refused. We can also see it here. So he didn't take the offer. He took 21 games in order to get his skin. In our previous one, he didn't take the offer again, and he took 22 games. In here, he took the offer because refused is 0, and as you can see, the run counter is much lower. It's at 12. He took the offer again, and our round count is at 8. And here he didn't take the offer, but he was really good at gathering coins, so he got it in 13 runs. So you can see that in average, when the player does take the offer and makes the purchase, it takes a lot less runs for the player to actually get his second skin, so it's kind of advantageous for him. You can also implement this mechanic for any other skin. As you can imagine, the more skins you get, the more complicated it gets, but results vary even more from case to case.
Absolutely. And so this has been a really great way of just kind of showing how we built our initial game model in around about 50 minutes during a previous webinar. We've then gone through and really looked at our monetization options this session. And it's really powerful, us being able to use this tool then within a couple of hours of starting to build this model from scratch, where we can actually now really use this to start thinking about how we can monetize this game, and building an offer like that where we can actually use the tool to identify those most common moments that will trigger a purchase decision. And we can then even balance the game further. We could carry on with this as much as we want. One of the really powerful things that we can then do is, we've been putting in some arbitrary numbers for the chances of somebody taking the offer or buying packs. What's really powerful about this tool is actually, rather than just having those at arbitrary average numbers, we can then adjust those to be, okay, let's simulate a player who has 100% chance of buying. That way, how quickly are they going to get through our content and unlock all the skins if they do buy keys and they do use keys and they do buy our offers? How quickly are we going to start to run out of content? And we can then use this to say, right, with our current development plans, we're going to have 10 skins. How quickly will a player that actually watches the ads and buys additional keys complete the game effectively and have all of that content? So we can then use this to then generate our development plans and say, right, we need to be releasing a certain number of skins at a time. Don't forget, if you add in more skins, are you diluting it? Are those new players still going to earn their skins fast enough? Do you have to adjust those mechanics? So literally within a little while, we can really start to get very powerful insights out of a Machinations model that really help us plan and build our games. Love to see if anybody has any questions around what we've built today or anything else about Machinations. please do drop them into chat. I know Mihai's been going in talking about things. One of the questions I did see come up was we've created some quite simple mechanics of there's a chance of a player watching an ad and there's a chance of them using a key. There might be occasions where we want something slightly more intelligent than that, because if a player dies in the first 10 steps, they might not use a key to do it. If a player is at 500 steps, they're really earning loads of coins, they might be much higher incentivized to use one of those keys or watch an ad to extend their lucky run. All of that's completely possible with Machinations. You know, it's done in a similar way where we're adjusting the odds using a state connection. We've tried to keep this model fairly simple-ish. Obviously, when you look at this model zoomed out, it can look quite intimidating, but really building those individual mechanics are quite simple. So as Cesar's been talking, I've gone through and just kind of been color coding a few things. So I've made my ad loop red, I've made my purchase loop purple, I've made my purchasing keys orange, just to really help identify and segregate some different areas. But there's a number of mechanisms you can do. One of the key ones being layers. So if you want to just quickly show some layers, Cesar.
We already have them. So prepare to have your mind blown. I'm going to be clicking on the eye. Poof. So you can hide things that you don't care about in a run. You don't have to see them. You can work around them. They are still going to execute during your run. So if you simulate, this part still executes. You just don't see it. You're focusing on your other systems. So again, you can focus on, let's say, your skins. You hide everything else. It's as simple as, let's say, taking this, selecting untitled layer, move selection to layer. So now all of this is in untitled layer. If I choose to hide it, it's going to hide. It's still going to work if I simulate. So it's as simple as that. It's the best way to keep your diagrams tidy, because as you can see, they can get quite complex. But this is a great way of separating your systems.
And it was a very deliberate decision that when I built the layer for the main game loop, I left the coins pool outside of that group. So actually, that's the only thing I care about is, you know, how many coins is the player gathering. So I'm leaving that in a separate layer just so that I can ignore all the noise and just focus on, you know, how many coins the player's creating. It'd be fantastic. Love to see if there's any other questions that anybody has. Otherwise, I think we'll wrap it up there. If anybody wants to, I'm going to end the recording in a moment. When you exit the webinar today, it's going to take you directly to a survey just to give us some feedback or any thoughts on this webinar. Also, any ideas you have if there's something you'd like to see in a future webinar. Once you've completed that survey, it's going to take you directly to this model. So you can actually go in, add this to your Machinations and start playing about with this yourself. If anybody wants to, once I've ended the recording, you're welcome to hang around. We'll do some more balancing and playing about with the model for a couple of minutes. And as always, I think Herrera is going to drop into the chat links to our Slack channel. Come and join us in there, and also into our Discord channel. So please do come and hang out with us and talk to us in Slack. There they are. Fantastic. Thank you very much, everybody, and enjoy the rest of your day.